Okay, so an exponential equation is an equation that contains the form b raised to the cx. Okay, so they give me a problem that reads 16 raised to the 3x equals 8. Same thing as this up here. This would be b, this would be c, and this would be x. So b raised to some number in x. That's all they're saying there. That is known as an exponential equation. So we want to take this exponential equation, we want to solve it. We work this just like we worked everything up to this point when we're looking at exponential equations. I need to find a base. What's my base? So 2 something 3x equals 2 raised to the something. So 2 raised to the what gives me 16? What? 2 raised to the what gives me 8? 3. The only thing different in what we've done and what we're doing in this problem is now we're going to take these two things and multiply them together. So I'm going to have 2 raised to the 12x equals 2 raised to the 3. Now what happens? My bases cancel. I'm left with 12x equals 3 divided by 12 on both sides, and I get x equals 3 over 12, which reduces to 1/4. That's my answer. That's how you work an exponential equation. And I just want you to solve it. And it has a common base. So these are exponential equations with common base. An exponential equation with a common base. What if I take this one? 27 raised to the 3x equals 81. 27 raised to the 3x equals 81. First thing I need to do is find a common base. What's my common base? So 3 something 3x equals 3 something. So 3 raised to what gives me 27? 3 raised to what gives me 81? What do I do now? Multiply these two right here together. So what does that give me? 3 raised to the 9x equals 3 raised to the 4th. What cancels out here? And I'm left with 9x equals 4 divided by 9, and I get x equals 4 ninths. Raised to the 2x equals 64. 256 raised to the 2x equals 64. What's my common base? 2. 2 raised to the what gives me 256? And 2 raised to the what gives me 64? So what do I do with these two? What happens here? My bases cancel out. I'm left with 16x equals 6 divided by 16, and x equals 3/8. Is it 3/8? X equals 3/8. So those are all problems with common bases. So now let's look at a problem that doesn't have a common base. So these are exponential equations with different bases. Exponential equation with a different base. So they want to know the solution to this problem right here. Solution to that problem. 15 raised to the 3x equals 285. Well, if I didn't know already that it was different bases and I tried to solve it, what do you think my base would be? 5. Well, 5 raised to the 1 gives me 5 raised to the 2 gives me 25. So under no way can I get 15. Do you see why I can't use a common base on this one? I can't say 5 raised to the 1 and 5 raised to the 2 and get 15. So I know right there that I'm going to have to use a different base. So this is what I'm going to do. The first thing I'm going to do is take the log of each side. The second thing is I'm going to use the power property, because this particular problem has the power property. The third thing I'm going to solve for x. And the fourth is I'm going to calculate my answer using my calculator. So, take the log of each side. That simply means that I'm going to put log in front of each side of the equation. The second one says the power property. Which one of these has a power? This one right here. So what do you think I'm going to do with that power? I'm going to move it to the front because that's what the power property tells me to do. So I'm looking at 3x log 15 equals log of 285. Now, my third step is to solve for x. So I want this right here by itself. What do you think I'm going to do with the 3, the log, and the 15? Divide. Why would I divide it? Because all of these are multiplied together. 3 times x times log of 15 is all multiplied together. How do I undo multiplication? By division. So I'm going to divide 3 log 15 here, and I'm going to divide 3 log 15 here. So the 3's cancel out, the log cancels out, the 15 cancels out, and I'm left with x on the left-hand side. On the right-hand side, I have the log of 285 equals 3, I'm divided by the log 3 log of 15, sorry. So in my calculator, that's what I'm going to put in my calculator. Log 285 divided by 3 log 15. Now, here's the thing about using your calculator. If you have a calculator that doesn't have the fraction button on it, you need to make sure that everything on the bottom is in parentheses because you're dividing the top by everything on the bottom. Okay? So make sure you tell your calculator that if you're not using the fraction button. Somebody tell me what they get. Yep.
No, it'd be 0.7. If you round it.
6, 9, 5, 7, 5, 8.
Wait, you don't want to round that?
Nope, I don't want 0.7.
Okay.
0.6958. So somewhere around 0.6958 is my answer for this problem. Because that means that it's approximate. It's an approximate, yeah. Okay, let's try this one. So I've got 5 raised to the 2x equals 130. 5 raised to the 2x equals 130. Well, let's see if the same base works first. What would my base be? 5. 5 raised to the 1 gives me 5 raised to the 2 gives me, and 5 raised to the 3 gives me, so I know I can't use a common base because 125 and does not match 130. So I know I'm going to have to take it and do separate bases with it. So what do I do in that case? Log of each side. Next step. What am I trying to get by itself? That right there. So what's got to be moved over? So everything has to go but the x. So what's log 130 divided by 2 log 5? So somewhere around 1.5122.